Hello learners, I am Rajat Tiwari, lecturer, Chhattisgarh Swami Vivekanand Technical University Bhilai and the subject matter expert of the course Essential of Surveying, Application and Techniques. Earlier on the subject, we have studied about fundamentals and basic principles of surveying. Now, we will be dealing with another aspect of surveying, that is compass surveying. So, what will be the learning outcomes of this topic? After studying this unit, the student will be able to understand the concept of compass surveying. They can understand what meridian is and the types of meridian, bearing, types of bearings, representation of bearing, conversion of whole circle bearing into quadrantial bearing. So, let us discuss what compass surveying is. In previous lectures, you have learned about chain surveying. So, in chain surveying, the control network at control points is established with the help of linear measurement, but in case of compass surveying, these control points are established with the help of both linear and angular measurements, and this process is called traversing. According to the method employed, surveying is classified into triangulation surveying and traverse surveying. A series of connected survey lines of known length and direction is called traverse. When triangulation is not possible, traversing method is used. In traversing, compass is used for making angular measurement and it is known as compass traversing or compass surveying. So, as you know, chain surveying can be used when the area to be surveyed is comparatively small and fairly flat, but when the area is large, undulating and crowded with many details, triangulation, that is the principle of chain survey, is impossible. In such an area, the method of traversing is used. So, let us discuss some basic differences between chain and compass surveying. In chain surveying, it requires only linear measurement, while in compass surveying, both linear and angular measurements are measured. In chain surveying, framework consists of network of triangle, while in compass surveying there is open or closed polygons are there. In chain surveying, check lines are required to check the accuracy, while in compass surveying accuracy is checked by method of adjustment. Chain survey is suitable to be used for small flat area where area required is less, but in compass surveying it is suitable for large area where accuracy required is more. So, what is the purpose and principle of compass surveying? Compass surveying is suitable in following situations. Firstly, when the survey work is to be completed quickly. Secondly, when the area is hilly and chaining is difficult. When the area to be surveyed is relatively large. When details are too many. When the area cannot be divided into network of triangles. And lastly, when the area to be surveyed is long and narrow, for example, roads, stream, etc. So, principle of chain surveying. A compass survey is one in which the traverse work consists of series of lines, the length and direction of which are measured with a chain or tape and with an angular instrument respectively. A traverse may be classified as closed and open traverse. So, what do you mean by traverse? Framework consists of number of connected lines forming open or closed polygon. They are called as traverse. Traverse are basically two types, as I discussed, closed and open. So, we will be discussing what is closed traverse. A closed traverse is a traverse which starts from a station and closed either on same station or another station whose location is already known. So, closed traverse can further be divided into two types. First one is loop traverse and second one is linked traverse. So, what do you understand by loop traverse? Loop traverse is a traverse which starts and ends at the same point whose location is known to us, and this type of closed traverse is termed as loop traverse, as you can see from the diagram. And what is linked traverse? If the traverse starts and ends at different points of known location, this type of closed traverse is called as linked traverse. Next, we will be discussing about open traverse. Open traverse is that where start location is known or established, but the station at which traverse is completed or closed is not known or established. These kind of surveys are done at roads, railways, etc. As you can see from the diagram, this is a open polygon where you can see A, B, C and D and E locations are there, in which we know the A location, but we do not know about the E, that is the unknown location. Hence, it is called as open traverse. So, for traversing can be done by any of the following method: compass traverse, plane table traverse, theodolite and by stadia. Here we will be studying about compass traverse. So, in compass traverse, magnetic compass is used for measurement of angle and chain, and tape is used for linear measurement. Measurement of angle: the direction of traverse line is defined by the horizontal angle which this line makes with the reference line, and that is termed as meridian. Now, we will be discussing about types of meridian. There are basically 4 types of meridian which we will be discussing. So, in compass surveying, meridians are reference lines used to measure the bearing of survey lines. These are several types of meridians, each serving specific purpose. Here are detailed look at the main types. Firstly, we will be discussing about true meridian. So, true meridian is a line that passes through the geographical north and south poles and a point on the earth's surface. It is a fixed reference, does not change with time. It is used for precise surveying and navigation since it is based on the earth rotational axis. Next is magnetic meridian. So, magnetic meridian is the direction indicated by a freely suspended magnetic needle such as compass, which aligns the earth magnetic field. It can vary over time and from place to place due to changes in earth's magnetic field. It is commonly used in compass surveying because it is easy to determine with magnetic compass. Next is grid meridian. The grid meridian is a line parallel to the central meridian of map projection. It is used in coordinate system such as Universal Transverse Mercator UTM system and is consistent within a given map grid, employed in large scale mapping and for navigation system that use grid coordinates. And the last one is arbitrary meridian. An arbitrary meridian is a meridian chosen for a convenience in a particular way, not necessarily aligned with true or magnetic meridian. It can be any line used as a reference for the survey, often chosen based on ease of measurement or local conditions. It is used in small localized survey where other meridians are not practical. Now, we will be studying about the types of bearing. Firstly, what is bearing? Bearing of a line is its direction relative to the line. What is true bearing? True bearing of a line is the horizontal angle which it makes with the true meridian through one of the extremities of the lines. Since the direction of the true meridian through a point remains fixed, the true bearing of a line is a constant quantity. Magnetic bearing. The magnetic bearing line is the horizontal angle which it makes with the magnetic meridian passing through the extremities of the line. A magnetic compass is used to measure it. And next is arbitrary bearing. The arbitrary bearing of a line is the horizontal angle which it makes with the arbitrary meridian passing through one of the extremities of the line. A theodolite or sextant is used to measure it. Now, let us see the figure. In the figure you can see the true north and true south, that is called the true meridian, and you can also see the magnetic north and magnetic south, that is magnetic meridian. So, you can see the line, the survey line OA which we have to measure. So, the horizontal angle between the true north and that the survey line, it is called true bearing, and the horizontal angle between magnetic north and the survey line, it is called magnetic bearing. You can see from the figure. So, now let us discuss designation of bearing, how we can designate the bearing. The bearing are designated into following two systems. First one is whole circle bearing system or azimuthal system, it is also called WCB system, and second is quadrantal bearing system which is called as QB system. So, we will discuss one by one. So, firstly it is whole circle bearing system. So, in this system the bearing of line is measured with respect to magnetic meridian in clockwise direction, it is called magnetic bearing, and its value varies between 0 degree to 360 degree. The quadrant start from north and progress in a clockwise direction, as the first quadrant is 0 to 90 degree in clockwise direction, second quadrant is 90 degree to 180 degree, third quadrant is 180 to 270 degree, and fourth quadrant is up to 360 degree. So, now let us check this figure and we will be discussing how we can measure the whole circle bearing system. So, referring to this figure, the WCB of AB line is theta 1, the WCB of AC is theta 2, the WCB of AD is theta 3, and the whole circle bearing of AF, the survey line AF is theta 4. So, we will be measuring from north and clockwise. Now, let us move on to quadrantial bearing system, that is reduced bearing. In this system, the bearing of survey lines are measured with respect to north line or south line, whichever is nearest to the given survey line, and either in clockwise direction or anti-clockwise direction. In this system, therefore, the quadrant in which the line lies will have to be mentioned. These bearings are observed by surveyor compass. So, refer to this figure. In this figure, we have to find out different bearing by the system of reduced bearing or quadrantial bearing. So, the quadrantial bearing of line AB is alpha and it is written as north alpha east. The bearing being measured with reference to north meridian, as it is nearer and it goes towards east. Now, the bearing of AC is beta and it is written as south beta east, being measured with reference to south and in anti-clockwise direction towards east. It is measured from south because the survey line is nearer to the south. Similarly, the bearing of AD and AF are south theta west and north phi west respectively, as the survey line AD and the survey line AF are nearer to the south and north respectively. Thus, in quadrantial system, the reference meridian is prefixed and the direction of measurement eastward or westward is affixed to the numerical value of the bearing. The quadrantial bearing of a line varies from 0 degree to 90 degree. The bearing of this system are known as reduced bearing. So, we have discussed about WCB bearing, WCB system, we have discussed about reduced bearing system, that is quadrantial bearing system. Now, we will be understand how we can convert the bearing from one system to another system. Firstly, we will be discussing about conversion of WCB system to reduced bearing system. The bearing of line can be very easily converted from one system to another. With the aid of diagram, the conversion of WCB into RB can be expressed in the following table. So, refer this figure. In this figure, there is true north, south, east and west. Now, we have 4 survey lines AB, AC, AD and AF. The first quadrant is referred to northeast, second quadrant is east, southeast, third quadrant is southwest and fourth quadrant is northwest. So, firstly we will be discussing about survey line AB. In survey line AB, we have given WCB system. So, in WCB it is in the first quadrant, that is 0 degree, from 0 degree to 90 degree. So, we have to convert WCB into RB system. So, what is the value in RB system? In first quadrant there is no change for WCB and RB. What value it is given in WCB? It is equal to RB system, only the quadrant will also be same here. So, RB is equal to WCB and quadrant will be northeast. Nextly, we will be discussing about the survey line AC. So, for survey line AC, WCB system is 90 degree to 180 degree and rule for converting into RB is 180 degree minus WCB. The quadrant will be southeast. So, from the figure it will be RB will be equal to 180 degree minus theta 2. So, for the survey line AD, that is in WCB it is from 180 degree to 270 degree. So, for conversion in RB it is equal to WCB minus 180 degree and the quadrant will be southwest. From the figure it will be theta 3 minus 180 degree. For the last survey line AF, WCB between 270 degree to 360 degree. So, rule for RB, so how will RB convert in 360 degree minus WCB and the quadrant will be northwest. So, RB will be 360 degree minus theta 4. Now, we will be converting RB into WCB system. So, check out this figure, and here it is given 4 survey line, again 4 survey line is given, and the system is given in reduced bearing system. We have to convert it into WCB system. Firstly, we will be discussing about survey line AB. Reduced bearing is north, alpha, east, and the rule for converting WCB, it is as equal to RB. There is no change. WCB, it will be between 0 to 90 degree in the first coordinate only. Next, we will be discussing about the survey line BC, survey line AC. So, reduced bearing will be south, beta, east, and the rule for changing into WCB is 180 degree minus reduced bearing. It is 90 degree to 180 degree. So, from the figure it will be 180 degree minus beta. So, for line AD, reduced bearing is south, theta, west, and the rule will be WCB will be 180 degree plus RB, WCB between 180 degree and 270 degree. So, from the figure it will be WCB will be 180 degree plus theta. For the last line, survey line AF, RB is north, phi, west, WCB is 360 degree minus RB, and WCB between 270 degree and 360 degree. So, from the figure it will be WCB will be 360 degree minus phi. Now, we will be discussing about compass and its types. A compass is small instrument essentially consisting of a graduated circle and a line of sight. The compass cannot measure angle between two lines directly, but can measure angle of a line with reference to magnetic meridian at the instrumentation point. It is called as magnetic bearing of a line. There are basically two types of compass. They are follows as the prismatic compass, and second one is the surveyor compass. We will be discussing one by one. So, prismatic compass, there are many components of prismatic compass which will be dealing one by one. The prismatic compass is a magnetic compass which consists of following parts. First is cylindrical metal box. Cylindrical metal box is having a diameter of 8 to 12 centimeter. It protects the compass and forms entire casing or body of the compass. It protects the compass from dust, rain, etc. So, what is pivot? What is pivot? Pivot is provided at the center of the compass and freely supports suspended magnetic needle over it. Next is lifting pin and lifting lever. A lifting pin is provided just below the sight vane. When the sight vane is folded, it presses the lifting pin. The lifting pin, with the help of lifting lever, then lifts the magnetic needle out of pivot point to prevent damage to pivot head. Next, the component is spring brake or brake pin. To damp the oscillations of the needle before taking a reading and to bring it to rest quickly, the light spring brake attached to the inside of the box is brought in contact with the edge of the ring by gently pressing inward the brake pin. Next component and the main component is magnetic needle. The magnetic needle is the heart of the instrument. This needle measures angles of line from magnetic meridian at a needle always remains pointed towards north and south pole at the two ends of the needle when fully suspended on any support. Next component is graduated circle or ring. This is an aluminum graduated ring to 360 degree to 0 degree marked with 0 to measure all possible bearings of line and attached with the magnetic needle. The ring is graduated to half a degree. Next is prism. Prism is used to read graduations on ring and to take exact readings by compass. It is placed exactly opposite to object vane. The prism hole is protected by prism cap to protected by prism cap from dust and moisture. Next is object vane. Object vane is diametrically opposite to the prism and eye vane. The object vane is carrying a horsehair or black thin wire to sight object in line with eyesight. Next is eye vane. Eye vane is a fine slit provided with eye hole at bottom to bisect the object from the slit and to take reading simultaneously from eye hole. This eye vane is provided with prism and can be lifted up and down by the stud to bisect the object of high level. Next is glass cover. It covers the instrument box from the top such that the needle and graduated ring is seen from the top. Next is reflecting mirror. It is used to get the image of an object located above or below the instrument level while bisection. It is placed on the object vane. Now, we will be discussing about some of the temporary adjustment of prismatic compass. The following procedure should be adopted after the prismatic compass on the tripod for measuring bearing of a line. The first one is centering. Centering is the operation in which compass is kept exactly over the station from where the bearing is to be determined. The centering is checked by dropping a small pebble from underside of the compass. If the pebble falls on the top of the peg, then the centering is correct. If not, then centering is corrected by adjustment the legs of the tripod. Next is leveling. Leveling of the compass is done with the aim to freely swing the graduated circular ring of the prismatic compass. The ball and socket arrangement on the tripod will help to achieve a proper lever of compass. This can be checked by rolling round pencil on glass cover. Next is focusing. The prism is moved up or down in its slide till the graduations on the aluminum ring are seen clear, sharp and perfect focus. The position of the prism will depend upon the vision of the observer. So, we have discussed about the temporary adjustments. Now, we will be dealing another type of compass, that is surveyor compass. It is similar to prismatic compass except that it has only plain eye slit instead of eye slit with prism and eye hole. This compass is having pointed magnetic needle in place of broad form needle as in case of prismatic compass. So, working of surveyor compass exactly same as the prismatic compass. What we have done in prismatic compass, that is, first one was centering, how we can center it, second one is leveling and third one is observing the bearing of line. First two operations are similar to that of prismatic compass, but the method of taking observation differ from that of prismatic compass. Observing the bearing of line in this type of compass, the reading is taken from top of glass and under the tip of north end of the magnetic needle directly. No prism is provided here. So, now let us discuss what are the difference between prismatic compass and surveyor compass. In prismatic compass, graduation circle is fixed to broad type needle, hence it will not rotate with the line of sight, while in surveyor compass, graduation circle is fixed to the box, hence it rotates with the line of sight. In prismatic compass, there is a prism at viewing end, but in surveyor compass, at the viewing end there is no prism, there is only a slit. Next, the magnetic needle do not act as an index in prismatic compass, while in surveyor compass magnetic needle acts as an index while reading. In prismatic compass, the graduation are in whole circle bearing system and we have studied thoroughly about whole circle bearing system, but in surveyor compass the graduation are in quadrantial bearing and we have studied quadrantial bearing also. In prismatic compass, graduations are marked inverted since its reflection is read through prism, while in surveyor compass graduations are marked directly, they are not inverted. In prismatic compass, the reading is taken through prism, while in surveyor compass the reading is taken directly viewing from the top glass. Hence, we have separated prismatic compass from surveyor compass. So, we can from this way we can differentiate about prismatic and surveyor compass. So, now let us discuss what is forebearing. The bearing of a line measured in the forward direction, that is along the progress of survey, it is known as forebearing. Forebearing will be equal to back bearing plus minus 180 degree. Now, let us discuss what is back bearing. The bearing of line measured in the backward direction is known as back bearing. Back bearing is equal to forebearing plus minus 180 degree. The plus sign indicates or applied when forebearing is less than 180 degree. The negative sign is applied when forebearing is greater than 180 degree. In the quadrantial bearing, that is reduced bearing system, the forebearing and back bearing are numerically equal, but the quadrant are just opposite. For example, if the bearing of line AB is north 60 degree east, then back bearing is south 60 degree west. Now, let us take up some examples. Firstly, we convert the following WCB into reduced bearing systems. These are some questions in WCB system and we have to convert it into reduced bearing. The first question is in WCB it is given 49 degree. Since the line falls in the first quadrant, therefore, the nearer pole is the north pole and is measured from north towards east as 49 degree. Therefore, reduced bearing for this question will be north 49 degree east. There will be no change in the angle. Next question is 240 degree. As you know, this comes in third quadrant. Since the line falls in the third quadrant, therefore, the nearer pole is the north pole and is measured from north towards south, as reduced bearing will be equal to WCB minus 180 degree. So, reduced bearing will be 240 degree minus 180 degree, which will be equal to 60 degree. So, the answer reduced bearing will be equal to south 60 degree west. Next question is 133 degree. So, as you know, this angle lies in second quadrant. Since the line falls in the second quadrant, therefore, nearer pole is the south pole and is measured from south towards east, as reduced bearing will be equal to 180 degree minus theta. So, reduced bearing will be 180 degree minus 132 degree, which will be equal to 47 degree. So, the answer, that is reduced bearing, will be equal to south 47 degree east. Next question is 335 degree. So, as you know, this 335 degree falls on the fourth quadrant. Since the line falls in the fourth quadrant, therefore, nearer pole is the north pole and is measured from north towards west, as reduced bearing is 360 degree minus WCB. Reduced bearing is 360 degree minus 335 degree. So, the answer reduced bearing will be north 25 degree west. Let us now convert the following WCB into RB. There are three questions, there are 180 degree, 260 degree and 315 degree. The first we will take up for 190 degree. So, in WCB it is 190 degree, reduced bearing will be WCB minus 180 degree. So, RB will be 190 degree minus 180 degree. RB is south 10 degree west. Next question 260 degree. Reduced bearing will be WCB minus 180 degree. Reduced bearing is 260 degree minus 180 degree. So, RB will be south 80 degree west. And next is 315 degree. Reduced bearing will be 360 degree minus theta, that is WCB. So, RB will be equal to 360 degree minus 315 degree. Hence, RB will be equal to north 45 degree west. Now, let us convert the following reduced bearing into whole circle bearings. Questions are north 65 degree east, south 43 degree 15 minute east, south 52 degree 30 minute west, north 32 degree 42 minute west. So, let us take first question in which we have to convert the reduced bearing into whole circle bearing. Let theta be the whole circle bearing. First question is north 65 degree east. Since it is in northeast quadrant, theta and alpha will be equal to, and the answer will be equal to 65 degree. Next question is south 43 degree 15 minute east. Since it is in southeast quadrant, 45 degree 15 minute will be equal to 180 degree minus theta, and answer theta will be equal to 180 degree minus 43 degree 15 minutes, which is equal to 136 degree 45 minute. Next question is south 52 degree 30 minute west. Since it is in southwest quadrant, hence theta will be equal to 180 degree plus 52 degree 30 minutes, which will be equal to 232 degree 30 minutes. And our last question, that is north 32 degree 42 minute west. It is in northwest quadrant, hence theta will be equal to 360 degree minus 32 degree 42 minutes, which will be equal to 327 degree 18 minute. This will be complete your question. Thank you.